Autodesk Inventor can use multi-loop sketches to define more than one feature from the same sketch. In this case, we have a layout sketch of an assembly. But we're starting in a single file, so rather than creating an assembly directly, we'll take advantage of multibody modeling. Multibody geometry can allow you to test fit components in a single file, making sure that all of the geometry fits together in the fashion that you need without going through the trouble of creating multiple files. If, however, you need those bodies as individual files, you'll have to go through a secondary process, which we'll take a look at. We'll start out by using the Extrude tool and selecting the lower profile. We'll make the extrusion symmetrical and set it out a distance of 60 millimeters. Expanding the extrusion in the browser, right-clicking, and sharing the sketch will make the sketch available for a second body. I'll start the Extrude tool again. Then we can select the profile, once again making it symmetrical but 22 millimeters. Because the sketch geometry is external to the original body, Inventor will want to join it. So what we need to do is select New Solid as the option. This will create the extrusion as a separate solid. If we expand the Solid Bodies folder, we can see that we have a solid for the base and a solid for the yoke. These bodies are held in place by their original position. We can make modifications to them as though they were separate components, but they are just separate bodies inside of our design. Selecting a body, you can even apply a different color specifically to that body. Now we can turn the sketch off. And I'd like to introduce another body into the design. This time, this body will come from a step file. Choosing Import, I can select the clamp step file and click Open. We're given the option to link this as a reference model or convert it to a solid. We'll go ahead and convert it, and this will add another solid body to the design. Using the direct modeling tools, in this case the Move option, and selecting the solids, we can pick this clamp element. We'll make sure that we can see the ortho face so we can get a good idea. We're just going to rough in a location for this clamp. We want it to be slightly above the base, so I'm going to bring it down 21.5 millimeters. We'll click Apply to place that clamp. With that body in place, we can close out of the direct modeling tools and start the Combine tool. What I'd like to do is subtract the clamp body from the base. So I'll select the base, then as a tool body, select the clamp body, subtracting it. This will create a notch in the side. Now I'd like to do a circular pattern, selecting that combine feature, and then using the y-axis of the model to create a second instance on the other side. Now we can use direct modeling tools to create some additional clearance, but for now, let's just leave those models as they are. What we have on the screen is effectively a representation of assembly made up just of bodies in the solid. What we'd like to do now is go ahead and publish an actual IAM assembly file and convert the bodies into IPT part files and link those into that assembly. To do that, we'll go to the Manage tab and select the Make Components tool. Selecting the base and the yoke, we can establish what the assembly name would be, select a template, and select a path. We can change out the individual templates for the part files and also change their individual part names. For now, let's go ahead and accept it as it is and click OK. After a moment, you'll see a new file has been opened, which is the VBlock assembly file. That VBlock assembly file, instead of having a base body and a yoke body, these are now part files that are linked to the assembly. We can make modifications to these files, make any changes we like. So if I were to activate the yoke, add a hole, I can reference the model edges like I normally would. You'll notice that this part is in inch units. So I have to use metric units to place the hole based on the dimensions I know. Make the hole all the way through. Finish off the thread specification. And place the hole. Now the hole that's been placed into this model is not in the original body. The hole is a child of this component. However, if we go back to the original part file and make a modification, we'll see what the results are. For example, let's go to the original sketch and let's change the overall height from 50 millimeters to 60 millimeters. In the sketch, we see everything looks good. We'll finish the sketch. The bodies update. Now, let's go back to the assembly file, and we'll see that the assembly file is out of date. Let's update it, and we see that both components and the assembly are up to date.